Okay, so that's the print array function from Monday's lecture. And the homework probably says something like declare an array of something, 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 and then print it out, right?
Well, here's my issue, because I tried to use the print array.
Yeah.
It gave me an error saying that it was missing the function definition. I think that's what it's missing up there,
Okay.
to get it to work.
Right, so what you would have to do is you'd want to move it from the other one into here. Even better would be if we were playing with putting multiple C files into the same project. But right, take that code and grab it from the other thing and then use it. But I'd also just like you to know how to print the array without using this function. So if we had, I'm going to delete that now. If we had an array, it doesn't really matter what kind of array it is. An array of strings, well, I better pound sign include strings if I'm going to do that. Is equal to, so I'm going to make this one called colors. It's going to be equal to, sorry, curly braces. We are taping, are we not? Yep. Red, green, blue. There's two easy ways. There's an easy way and a slightly more difficult way. The easiest way is with the range-based for loop. For string, I'm just going to use V for value. V colon colors. C out arrow arrow V. Arrow arrow ENDL. That would print it out. This prints it out by value with a range-based for loop. We can also print it out by index, but when we print it out by index, we have to know how long the array is. We could hard code that. We could define a constant. So constant int color length equals 3, and we could stick, or we could calculate it on the fly. And that's how I'm going to do it. You can only calculate it on the fly if you're accessing it in the same context, in the same scope in which you declared the array. Like if we pass this array to a function, like that print array function, it wouldn't work. That's why that function that we wrote had a length parameter. But here we could. So int color underscore len is equal to the size of the array, size of parentheses colors, divided by size of a string, like that, because it is in fact an array of strings. Now we know how many items there are, how many colors there are, and we can write a for loop or a while loop. So we need a counter. I is as good a counter as any. For I is equal to 0, I is less than color underscore len. We could have just made it 3 if we had hard-coded that magic number, or if we declared a constant, we would have used that variable. I++. And then inside the for loop, the same kind of thing. C out, but we need to reference it by its index number, by its subscript. So C out, colors, subscript, I in subscript, arrow, arrow, ENDL. I'd like for you to memorize that and be able to say it on an exam or something without having to go back and look. This one right here is super easy, right? These, if I tell you to print out an array, you could write a range-based for loop to print it out just with 2 lines like that. That's really short. Conceptually, I want you to have this one as well, but if you had to look it up, that's okay, but I want you to have it as well. You just need to know that you're going to have to know what the upper limit is. And how are you going to figure that out? Well, using size of is one way. Defining it as a constant is another. The absolute worst way is to just stick the number 3 in there. That would work, but it's really poor form, because what if the number of colors changes?
Thank you.
Sure.
Mine is highlighting the word colors with red.
Let's move that brace 3 to after colors. I think I put the brace in the wrong place.
Thank you.
Sure, and my mistake. I need to point that out. Okay, so it was a mistake for me to put the curly braces there, the square braces there. Why do we say that? Because if we actually hard-coded the number there, then Sparks is seeing it not work. Now, of course, it may work for me anyways. Nope, okay. Really, the square braces is supposed to follow the variable name, like that. Now, if you're doing Java, you're probably putting the square braces there after the variable type. And so I get goofed. That was my fault. It's interesting that this actually worked, but when we tried to fill it in with a number, it didn't work. Can't explain why. Well, I mean, I guess I should actually make sure that that works, but I know that it will. Errors. What is it doing? Oh, I called it .c rather than .cpp because I just walked in here for my .c class. Let's rename the file. .c stands for just a C rather than C++. So .cpp. Maybe it'll build now. All right. Get rid of that little hashtag in front of using. I was being sloppy there. All right, and it actually works. And if I had put the 3 there, as was the question, would that have worked? And the answer is probably no. Yep. Well, fascinating. I need to figure out why that worked without it. But the correct way in C++ to declare an array, to denote as array, is to give it a type, and then a variable name, and then a square braces. And if you goof that up like I did, may compile, may not. Did we skip a chapter? Were we on 5 and then we went to 6, but we didn't do 6 and instead we went to 7? Did I do that on purpose? And you're going, I don't know, why are you asking me? Oh, that's why. What do you know? All right, we've learned a lot about arrays. We're going to step back and learn about functions. How about that? Okay, we already have kind of the idea of functions, though, from your Python classes and things like that. So, but we're going to hit it for reals now. The idea of a function is that it's a named block of code. It's code that's got a name, and along with the name, you define what data you can pass into it and what data type it will return. And the idea of functions is modular programming, breaking a program up into smaller manageable functions or modules. That gives you the ability to split the task up between multiple programmers. You say, okay, I want you to write these modules and I want you to write these modules. Why would you bother doing that? You can have multiple people working on it. You can improve the maintainability of programs. What does that mean? Well, instead of having a chunk of code that's repeated 20 times, you know, some printing of an array, some loop that does that, you can put it into a function, and then you can get that function absolutely perfect, and then you can just call that function over and over. And then you can even take it into another project and use it. So if you've already built up a library of functions, that simplifies the process of writing programs. You know, you can just reuse functions that you've written from another project. So the function is a collection of statements that performs a task. And here's our silly example. But we have main, and it's got a whole bunch of statements. Well, why don't we spivvy it up? We're going to have a main, we're going to have a function 2, and a function 3, and a function 4. And this example does not work because it doesn't ever call function 2, function 3, or function 4. If this example was written adequately, what we would do is main would call function 2. Main would call function 3. And main would call function 4. But without it calling those functions, this is useless. So this is a poorly written slide. Defining and calling functions. In Python, you use the def word. In this language, you don't. In this language, if you want to create a function, you give it a type, about int. You give it a name. We're going to add 3 numbers. And then inside the parentheses, you list any parameters, any arguments that it's supposed to accept. And if there aren't any, you don't put anything there. But let's make this one accept 3 ints. Int A, int B, comma, int C. And all it's going to do is add up those 3 numbers and return them. That should have been int space C. So inside there, we're going to declare a local variable. Int total is equal to A plus B plus C. And then we're going to return that total. Now let's write another one called mult3 that multiplies 3 numbers. It's going to be very similar, except instead of add 3, it's going to be mult3, and it's going to return A times B times C. I feel like cheating and just copying this one and making some changes. So I'm going to copy add 3. I'm going to paste it and call it mult3, M-U-L-T3. And instead of the total being A plus B plus C, it's going to be A times B times C. So the int indicates the data type that is being passed back. Total is an int, so the function has to be defined as an int because that's what it's returning. Here total is defined as an int as well, so it has to return an int. If we wanted it to return a string, we'd make it string mult3. If we wanted it to return a double, we'd make it double. Now, Python, you didn't define the data type of your functions. You just used def. You didn't say that it was going to return an int or a string or whatever. But on the other hand, in Python, you didn't give your variables data types either. So now when you're ready to use them, you just call them by name. Int x is equal to add 3, 1, comma 2, comma 3. Int y is equal to multiply 3, 4, comma 5, comma 6. Now, just like as in Python you had to define your modules, your functions, before you could call them. They had to be above your code. Well, that's sort of true in C++. They have to be what's known as forward declared. But that doesn't mean that the whole function has to be there, up above main. But if you take them out, if you move them somewhere else, it does have to know how it's defined. So I'm going to take those two functions, add 3 and mult3. I'm going to cut them. I'm going to move them to below main, and now my code will no longer compile. So all I did is I took those functions that I had above main, compiled them. I mean, not compiled them. I cut them and moved them down here, and that's going to break the code. So if I do rebuild, it says rebuild failed. It says add 3, identifier not found. And this is probably what you were seeing when you were trying to use print array, be my guess.
No, it said that the function definition wasn't there.
Oh, okay.
That size of whatever you had wasn't there.
Oh, okay, okay. So anyways, in order to get this to work again, we have to tell the compiler what kind of data add3 is accepting, what kind of parameters, and then what kind of data it will return. So we have to define prototypes. The easy way to declare a prototype is just to copy the function header. I'm going to copy that line, come up here, paste it, and put a semicolon there. That's all a prototype is a function header with no body. And it's there to tell the compiler that when we want to invoke add3, we'd better pass it 3 ints. When you're defining your prototype, you don't even have to put the variable names. You could remove the variable names, and you could just say, I'm writing a function that accepts 3 ints. I don't always bother doing that. Sometimes I like the variable names. They give you useful information about what the function's supposed to do. But we had 2 functions, didn't we? So let's write the other one as well. Multiply 3 also returned an int, so it's defined as an int, and it accepted 3 ints. Int, comma, int, comma, int. So its parameters are 3 ints. Why do you need those prototypes? To forward define the function, to let the code know how add3 and mult3 are to be called. Without it, it can't compile it. So you either have to define your function itself above the code where you're calling it, or you have to have a prototype for it. Typically what people do is they will put functions in a separate .cpp file, and they will make a header file that has the prototypes.
Professor Thompson,
Yes, sir.
I guess this is where I'm getting lost, because right there you just have a prototype, right?
Right.
What exactly do you have to define? Like what point do you have
The
to have
functions itself are down here below main. And if I took them out and compiled it, it will compile, but it won't link because it doesn't have those functions available to it. It's going to say unresolved external int. That's exactly what you were getting, which means that you had a function prototype, but you didn't actually have that code itself. So I'm going to paste those things back in or undo my change. These could be in the same file or they could be in a separate file. I'm going to move them to a separate file just for funsies. Go back down to the bottom of main, cut them. I guess you could copy them and delete them later, but cut them. And then let's make a new source file. I'm going to do add new item. It's going to be a CPP file. And I'm going to call it funcs, F-U-N-C-S. Or heck, why not just a whole word, functions. And then paste those functions in there. But this kind of needs the same kind of boilerplate, really. So I'm going to add that boilerplate to this one as well. # include. But this guy isn't using any I/O streams. So we could probably leave that out. I'm just going to compile it and see if it'll work anyways without that there. Well, I never had it print the results of add3 or mult3, so we can't see that it's working, but it is. Let's add a cout to each one of these statements. Cout, and then now we are going to have to add that # include to get it to work. Cout add3 is returning end quote arrow arrow total arrow arrow ENDL. Now it doesn't know what cout is and it doesn't know what ENDL is, so we better go and add our boilerplate. # include IOStream using namespace std. That'll get those to go away. And then put a similar cout statement in the mult3 one. You just cut that one, copy that one and paste it into Mult3 and modify it. So I'm going to do that as well. I'm going to grab that, paste that there, and instead of add3 is returning, I'm going to say Mult3 is returning. That way I can just see that it was invoked. All right, and it says add3 is returning 6 and Mult3 is returning 120. Sounds right. Typically what you do, if you're going to move your functions to another file, you move your prototypes to a header file. Let's do that. So we have our prototypes over here in our original CPP. Just cut those prototypes. Highlight them, cut them, and let's make a new header file. The header file is going to be called functions.h. So I cut those out of July11.cpp. I'm going to come here to source files and do add new item, create a .h file, and instead of calling it header.h, which is way too vague, I'm going to call it functions.h, which is just a little less vague. And I'm going to paste in those two prototypes. But for this to work, I have to include that header in my other files. I need to put a #include to include my own brand new header. So I'm going to go back to both of those programs that I've written and add another line that says #include, but it's going to say #include functions.h. But it's not going to have the angle braces around it. It's going to have quotes around it. So I'm going to do that. I'm going to go to July11.cpp, the one that just lost those prototypes. And up here in my includes, I'm adding one. #include, angle brace, functions, angle brace function. No, except I'm not going to use angle brace. That's wrong. Quote, functions.h. So why did I use quotes rather than angle braces? Angle braces says to go and search the include path. You know, there is no IOStream header file right here in our source files folder. There is no string header file right there, but there is a functions.h. So this is saying don't search the search path for it. Just open the file in the same directory. So that's why we put quotes around it. Quotes means that the header file is enclosed in our own source directory. Angle braces means go and look in the C header files for it. All right, if I haven't botched it, it should still compile and run. Add3 is returning 6, Mult3 is returning 120. Okay, I want to pause it and make sure it's working for everybody. An error you might see is that a function was multiply defined. In here, my functions.cpp, I have a function called add3. What if I'd left that also in my July CPP? Below or above it, it doesn't matter. When I build it, it's going to give me an error. Rebuild solution. What it's going to tell me is already defined in functions, one or multiple symbols found. You can only have that function in one file. You can call it from as many files as you want, but you can only have one block of source code with that name in one place. And right now this function is multiply defined. It's inside July.cpp and it's inside functions.cpp. I would need to remove it from one or the other, and until I do that, it would not compile. And that's why you were getting main doubly defined, because you had copied main.cpp into functions.cpp. Because when I told you to copy the functions, I wasn't very clear about which ones to copy, so you moved main over as well, in which case you had two mains. Now I'm being a little bit more aggressive about showing y'all setting up multiple CPP files and header files but that's just because I know that y'all already have the concept of functions from your time as Python programmers. So when you define your function, you define its return type. Is it going to return an int? Is it going to return a double? Is it going to return, if it's not going to return anything, you call it void. Your fundamentals class may have used the distinction void functions versus fruitful functions. Well, here we actually use the word void to declare a void function. A void function is one that doesn't return anything. You give it a name, follows the same rules as variables. And you give it a parameter list. Parameters are variables that receive values passed to the function. We had 3 parameters in our functions. That's a variable that receives a value, that's a variable that receives an int, and that's a variable that receives an int. So when this function calls it, when main called it, it passed in 3 arguments. And this 1 filled in A. This 2 filled in B. And this 3 filled in C. So parameters are the variables and arguments are the data that is passed to them. But it's easy to mix those 2 things up in casual conversation. You know, I might say, well, I better pass in 3 parameters. Well, technically those aren't parameters, those are arguments. You might be writing the thing and you're going to say, okay, well, he's going to have 3 arguments. No, technically those are parameters. Parameters are the variables. Arguments are the values that get passed in. Am I going to yell at you if you make that mistake? No, because I do it the same thing when I'm talking. The concepts are similar, very, very interrelated, but they're not the same. And then the body, the statements that perform the function's task. And then lastly, the return statement. If its return type is void, you don't have to have a return statement. But if its return type is anything other than void, like in this case int, you do have to have a return statement. Now, if you're taking Java, you'll have noticed, it's totally okay to have a return statement even in a void function. However, the Java compiler will warn you about that, like, you're not supposed to do that. That's absurd. That's one of my pet peeves. But let's write a function in above our main.cpp, just called say hello. Let's make it accept a string as an argument, string name. And we're going to print out hello, comma, space, end quote, semicolon, and then let's write out their name, followed by a couple of nice snazzy exclamation points. So see out error, error name, error, error quote, exclamation point, \n. And then return. Now since it's void, we don't tell it to return in anything in particular. We're not returning X or Y or total or anything. So we could even remove that statement and it would still compile. So down in main, I'm going to come down here and I'm just going to call say hello. Say hello, Bob. So when it runs, it's going to say hello, Bob. Yep. Hello, Bob. It's still cutting things off at the edge of the screen. I need to remember that I'm missing like an entire ½ inch on my screen. All right, anyways, hello, Bob. So the function was invoked. We had an argument, a parameter to fill. The name of the parameter was name, and it was filled with the value Bob. This is known as pass by value or pass by copy. name got a copy of this data. If I declare this as a string first name is equal to quote Bob, and then I pass that in instead, so if I change the call from say hello to first name, then this gets a copy of that data. This is not the same variable. What do I mean by that? If in here, for some reason, I thought I'd be well, let's compile it and make sure it works first. But if I try to change that value, it's not going to change. It's passed in by copy. It's like we got a Xerox copy of that name. And so later on, if we try to change it, it's not going to do any good. So yeah, what if I was a prankster and I went in here and I did name is equal to Joe, like that, before my return statement. And then I came down here, and after I call say hello, what if I print that variable out? I print first name out. So cout after call first name equals space end quote arrow arrow first name arrow endl. Heck, move that name equals Joe up above the hello statement. Take that line, cut it, and move it above the hello statement, just for the point of this little exercise. So now my say hello method looks like this. Name is equal to Joe, cout the word hello, cout their name, which we've just reset to Joe. And then so we create a variable called first name. We call say hello, passing first name as our argument. And then after it's done, we print out first name. Now we might expect that first name will get changed, right? Because if we change it right here, we change the name variable. If we print it out, it's going to say hello Joe rather than hello Bob. But when we get back here, first name is still going to equal Bob. So when I run it, it's going to say hello Joe, and then it's going to say after call first name equals Bob. Hello Joe, after call first name is equal to Bob. So what happened here? It passed the contents of this variable in, that say hello variable. It passed in a copy of it. So this function has a Xerox copy of that name. It can scribble all over it and put something new on it, but he still has the original. It's just a copy, passed by copy, passed by value. What if you wanted this function to really be able to change it? You can do that and pass it in by reference. Python didn't give you the ability to pass in by reference. Java does not have a pass by reference operator, but C++ and C# do. If we wanted this say hello function to actually be able to change the contents of first name, we would come up here and we would use an ampersand in front of that variable name. So by adding that, what this parameter is not a copy of the contents of first name. This parameter is a reference to first name. They're the same variable. So any changes made to that variable in here will stay true here as well. And so now it's going to print hello Joe, and it's going to come down here and say after call first name is equal to Joe rather than Bob. It has actually changed the value. So hello Joe, after call first name is equal to Joe. That's passing by reference. If you take that out, it's doing a pass by copy. And that's typically what you've learned now in all your other programming languages, unless you're a C# programmer. So return type, function name, parameter list, but this one's empty, no parameters there, meaning you're not going to pass any arguments to it. And then it's got some braces, and between the braces it's got some body. And after the body, but before the closing brace, our return statement. So if a function returns a value, the type of the value must be indicated. If it's returning a value, it's got to be some data type that it understands, an int, a string, a float, some data type that you define. If a function does not return a value, its return type is void. So this one just prints a heading, but it doesn't return anything. There's no return statement, so we declare it as void. So calling a function. To call a function, you use its name, followed by parentheses. If it has to fill in any parameters, you put some arguments between the parentheses, and then there's a semicolon. And then when the program runs, at that point in the code, the body of the function will be executed. And when the function terminates, execution resumes at the point of the call. So when I come here, and I'm watching it run, we call say hello, which means that processing jumps up to here, and then it executes these lines line by line, and then when it hits a return, it comes back down here. And we can watch it do that if I set a breakpoint. I'm going to come and click over here, and I just click there to put a little stop sign there, a symbol there. And so now if I do local Windows debugger, it runs and it stops there. We see the arrow indicating that that is where it stopped. And so I have to find the little debug icons that let us move from function to function. And there's 4 little icons. If you've installed Visual Studio yourself on your laptop or your home computer, then the icons will look a little bit different. But what you're looking for is step into versus step over versus step out. Step into means jump into a function. Well, this isn't a function, so I'm not going to step into anything. Oh, great. The recording's not showing the star. Drag that over. There's our little arrow. So that is the line that we are currently on. But we're going to skip that line. We're going to go to the next one. So I'm going to find the symbol. That means, where's my toolbars? The one that says step over. So when I do step over, it skips from that line to that line. Now this is a function. I could choose to step over it as well, in which case it'll run up here, do the say hello function, and then come back. Or I could actually step into the say hello function. So another one of the symbols means step into. So if I do that, it jumps. Well, it's showing something. It's actually doing a whole bunch of stuff I wasn't expecting to see. It's stepping into a whole bunch of stuff for copying that string, which is getting really annoying. So I'm going to do step out, see if I can get out of here. And I'm going to try step in one more time. All right, that finally worked, but that would have frustrated me enough that my fix for that would have been to stop debugging. I would have found that little stop symbol. And then I would have set a breakpoint right here. Because if that's the function that I'm interested in, I would set the breakpoint there. And so now when I go back into the debugger, see there's a debug stop, except there's no reason to stop because we're in the middle of running. But it stopped at that. What it did is it ran main, it's created a variable first name, it called say hello, so execution jumped up into that function. It got to the first line, and that's where the breakpoint was set, so it stopped there. Now when I'm ready to stop it for reals, to kill the whole program, I'm going to click that red square that says stop debugging. And that's also available under the debug menu, stop debugging. But let's watch it do it. Somewhere we can find our variables. If I come over here and look at locals, I'll see that there's a variable called name, and it's set to Bob. So if I click step over and let it do that, it finishes that statement, and name has now been changed to Joe. It was Bob, now it's Joe. I'm going to do another step over. And what did that do? It counted. So if I go and look at my results, I will see that it did print the word hello there, because that's what that line of code did. What is this line of code going to do? It's going to print out the name. Well, that's where we are. Let's step over that line. And if I go back over here, it did print out the name as well. All right. Now let's say that I'm tired. There could be more code in this function, but let's say I was tired of being in that function. I could do step out, which means pop back out of the function. And when I do that, it returns to where it was. You know, this is the calling code, so now it's ready to start going to the next line. And now there's another cout statement there. If I wanted to, I could now step into that and watch it call add 3. I'm going to do that. One of these buttons is step into. I'm going to click that, and now we're going to be inside the entirely new .cpp file. Step into, okay, now I'm inside add 3, and I can watch it add those numbers together. Notice that my local variables are different now. It's saying that I have a variable called A, and a variable called B, and a variable called C, and a variable called total. So I'm going to do a step over, let it execute this int total equals line. It has executed that line, so total has been set to the value of those three things added together. And so total is equal to 6. Now I'm tired of being in this one, so I'm going to do a step out. And it comes back to where we were. And I don't want to step into molt3. I'm kind of tired of all this stepping into business, so I'm just going to do step over. And then I'm going to do step over again. And it does run molt3, it just our debugger doesn't step into it. We don't get to see it run. And so on. We could keep going down. You know, we could watch it loop if we wanted to. Step over, now we're in a for loop. What is V equal to? Well, the first color is red, so V is equal to red. And then we step over, now what's V equal to? Green, the second color, red, green. So now we're pretty sure that if we step over a third time, V is going to equal blue. Right? Yeah. And now when we step over one more time, we're at the end of our list. We didn't have any more than 3 colors, so our for loop is done. But it first has to check it. It comes back up here, but it's done. And so it skips to the rest of the code. Now that's about enough of that. I want y'all to get good at debugging, but it's something you ought to play with. Just set the breakpoint for the first line of code in your main, and then do step over, and watch what it does. Yes, sir.
Just real quick, the void say hello, that whole function. If you would put the void say hello, that first line in the header, and the whole function in the functions, would all you need is that, you wouldn't need the prototype, you'd be able to say hello in the main?
Right, that's what we did, is we put this code above main.
No, I'm saying, like, in order for you not to have that code in there, can you split it up, like you did the others, put the void say hello into the header, then the whole function into the function CPP, and then just keep the say hello in the main, would it work?
Yeah, if we had a prototype for it. Let's move this to our functions file, our funcs.cpp. I'm going to highlight all that, cut it. I'm going to go to functions.cpp and paste it. Now it refers to strings, and that's not part of our boilerplate up here, so we're going to have to do # include string there. All right, all well and good, but we better add a prototype to our functions.h as well. And so let's do that. Void say hello string. Now, using a later version of Visual Studio, when you create a header file, it adds this line to it. You will see this if you're doing this stuff at home with something later than Visual Studio 2013. You'll see it say pragma once. What that means is no matter how many times this file is included in a .h file, really only bring it in once. And it says declaration is incompatible with void say hello. Declared at line 4. Oh, now that error went away. Well, that was odd.
It's doing that for me too.
When you control S it and rebuild it, I bet the error goes away. Or not. Now I have 3 errors. String is an undeclared identifier. Alrighty. Well, we don't have string in our headers here, so yeah, so # include string there. Really? Oh, and then using namespace std. Except that does not go with a pound sign in front of it. Using namespace std. Alrighty. Okay. So since we are including string here, we could conceivably go and remove our pound sign include strings from the other file. Otherwise, we're bringing that code in more than once. But it's okay because string is defined with that pragma once up at the top. Just like that. So even if our logic, if our chain of includes would bring this string header file into our code in more than one place, that pragma once means nah, just ignore it anytime after the first time you see it. So calling functions. Main can call any number of functions. Functions can call other functions. But the compiler has to know about a function before it's called. The compiler has to know what its name is, what its return is, the number of parameters, and the data type of each parameter. And that's what you use a prototype for. So that the compiler knows that when I call say hello, I better be passing a string to it and that it's not returning anything. So function prototypes, it's just the header of the function, but it's got a semicolon at the end rather than a body. And when I was doing my function prototypes, I was leaving out the variable names. But you don't have to. Where we had add 3, it could have been A1, A2, and A3, or A, B, and C, or whatever they were over here in functions. I don't remember. Oh, they're A, B, and C. Now variable names, parameter names, are sometimes very useful information. So I usually leave the variable names, honestly, rather than cut them out. But technically, that's all you need is a list of the types and not give the variable names. For example, say hello. That function accepted a variable called name, I bet. So I could modify the function prototype to match string name. And now when I'm looking at the prototypes, I understand a little bit more about that function. That what I'm going to be passing to it is a name. Tells me a lot more than just knowing I'm passing a string to it. So I like having the variable names in the prototype. Yes, sir.
I'm still coming up with errors.
All right, let me hit. I like psych. So over here in functions, at one time, say hello had an ampersand here, right? And then I removed it. You didn't see me remove it. So then when we went over to functions.h and I typed in string name, this one doesn't have the ampersand. But on your side, say hello does. So just make a match. Either remove the ampersand from say hello or come and add it to the function prototype. Just make sure they match. I'm going to put them in both places now. Let's keep going. So, prototype notes. Place the prototypes near the top of the program. And I'm going to add in parentheses, or better yet, in a header. The program must include either the prototype or the full function before the call to the function. Otherwise, you get a compile error. So above main, there'd better be either the function itself or a prototype for it. When using prototypes, you can place function definitions in any order in the source file. And you can put the function definitions in other source files. So that ought to be a comment too. Or in other source files. Sending data into a function. You do that with parameters. So we've seen POW before. A and B are arguments. And then wherever the POW function is written, it has been defined to accept 2 parameters. So the variables that hold those values are called parameters. A and B are arguments. We don't know what the parameters are called. We could write that code and then open the header file and see. This is just for curiosity's sake. POW 1, 2. All right, now I'm going to right click on POW and say go to definition. Alrighty. They called their variable names left and right. Good enough, I guess. But you can do that on your own code as well. I'm editing my code. I don't remember where I stored the say hello function. I just highlight it, I right click, I do go to definition. And it takes me into the CPP file with my say hello function. So if we really want to get all academic, the parameter can be called a formal parameter or a formal argument. And then the argument can be called the actual parameter or the actual argument. So I don't know why they're giving us so many choices, but if you go and take another programming course somewhere else, then when you're looking at your code like this and you're looking at say hello, then you can go, okay, that is my formal argument. And then you go and you look where it's being called and you say, that is my actual argument. And you have to say it with a snooty tone. No, I'm kidding. If you feel like remembering that, if you feel like remembering that the parameter is the formal definition and that the data that you pass to it is the actual, sure. But pretty much every textbook that we're using at this school right now calls them parameters and arguments without using the word formal to distinguish where they are stored, where they are declared, defined. So the value of the argument is copied into the parameter when the function is called. The parameter scope is the function which uses it. So we had some functions inside functions.cpp. His scope is between here and here. We couldn't write another function that's going to use this A. Void func, void dummy, like this. I can't do A is equal to 12 there, right? Because obviously this variable exists only from here to here. So I can't get away with doing that. A function may have multiple parameters. It can have none. If it has multiple parameters, there must be a data type listed in the prototype for each one. If it's going to have 3 parameters, say the first one's an int and the second one's a string, and the third one's a double, that better be in the prototype and it better be in the function definition as well. When you do it in the function definition, you better give the variables names. In the prototype, it's optional to give the names, but like I said, it's useful information. So variables in a function that hold the values are passed in as arguments. Those are called parameters. Yeah, we've said that a couple times. So display value. Num is our parameter. When we call it, we're going to pass an argument in that's going to fill in that variable so that when it runs, it's going to say the value is, and it's going to fill that in. All right, so when we were defining our function prototype, what this is trying to tell us is that in the prototype you don't have to give it a variable name. When you're defining the function itself, you do. But like I said, there's nothing wrong with using a variable name inside the function prototype. So the value of the argument is copied into the parameter when the function is called. Okay, I seem to have hit this slide a second time. Arguments will be promoted/demoted as necessary to match the parameters. Meaning that I have this function called add3. What if I'm passing in data of the wrong kind? Is that going to work? What if I do int x is, okay, I already have something called x. X is equal to add3 and I pass in some doubles. Is that going to work? Well, in this language it will.
What's the round it down?
Yes. Yeah. Java will not do that. Java will say, you don't have any functions that'll accept floats, so I'm not going to hook you up. But C++, being a little bit more generous, says, okay, we could force those floats to be ints, and they're just going to be rounded down. So when it runs, it's going to round down to 1.2 to an int. It's going to demote it to an int. 2.3 is going to be rounded down to 2, demoted to a 2, and 4 is going to stay a 4, and so 1 plus 2 plus 4 should say 6 when I run it. X is 7. Was I expecting it to say 7? Yeah, it was, because 1 plus 2 is 3, plus 4 is 7. Okay. What if you go the other way? Well, like if we don't necessarily type this, but, you know, void ugh, and it takes a double. Does something with it, whatever it's going to do. Down here, when I call ugh, if I pass it an int, no problem. All languages know that you can take an int and you can promote it to the next higher data type. Java won't allow automatic demotion, whereas C++ is happy to do so. The reason Java doesn't want you to do that is because you have data loss, right? Values are being truncated. Values are being rounded down. I would like to know that when I'm writing this code, that that's an unsafe operation. That's going to result in the rounding down of my data. The Java compiler flags that as an error. Maybe this flags it as a warning. Let's find out. It doesn't even flag it as a warning. Okay, but I see one warning. Conversion from a double to an int, possible loss of data. Okay, good. It is giving us a warning about it. It's kind of subtle. We didn't see it, but it is there. It's a 4,000 level warning. Quite often people just ignore all the 4,000 level warnings. But this one worked fine. We didn't get a warning about this because taking an int to a double, there's no data loss. You can take an integer and store it in a floating point variable, and there's no rounding that happens. It's only when you're going the other way that you can have data loss. So it's called promoting if you're going from the lesser data type to the larger data type. That doesn't involve any data loss. It's called demoting if it goes from a larger data type to a smaller data type, from a float to an int, something like that, or from a long to an int, or from a double to a float. So whenever there's the possibility of data loss is there, it's called variable demoting or type demoting. Other languages will generate compilation errors if you try to do that. C++ doesn't care. It's happy to let you do it. Just gives you a little warning. So this is very similar to the function that we wrote. They wrote one called show sum. It takes 3 ints, int num1, int num2, and int num3, and it couts those 3 values added together. Passing data by value, that's what we're doing. Passing by value, that's when the argument is passed to a function, and its value is copied into the parameter. Changes to the parameter do not affect the value of the argument. Just like when we were originally doing that name is equal to Bob business. It didn't modify the variable that had passed the data into it. It just modified the local copy of it. So, we have a function called even or odd. We must have written it earlier. Its parameter is called num. The argument being passed to it is called val. The data contained within that argument is copied into this parameter. And then if this function changes it, well, he's still got his original. So even or odd can change the variable num, but it does not have any effect on this variable. If you define it as a reference with that ampersand, it really will change it though. You may think to yourself, well, why don't I just make everything a reference then? Well, there are things that you can do with reference variables and things you can't do with a reference variable. if I go into my code and I decide that I want to make this a reference for whatever purpose, I've just decided that references are cool and I'm going to make all my parameters references. Now when I compile it, this doesn't work. Why? Because it's wanting a double to match this double. Now one could be converted to a double, but it doesn't want to see a conversion. It wants to see an exact match of the data type. You know, like what if this said x is equal to 10? Is that magically supposed to change that 1 to a 10? And everywhere else that we have a 1 written, suddenly it's going to become a 10? No, no, it just does not make any sense to have a literal constant come in here and then have its value change like that and have it be permanently affected with a reference. So you just cannot make a reference if what you're passing in is a literal constant. Okay, well, let's say, okay, I'm going to be smart. Const double value is equal to 1, and I'm going to pass that value in. Nope, it still doesn't like it. Why? Because this one is a const and this one isn't. So I could fix that by coming up here and making that a const. Now it's all clean, but, whoops, now we can't be changing the value of it. Well, if you were making this a const, then why were you trying to change the value of it in the first place? Why did we make it a reference? But you can make a constant reference. You just can't change it once it's in there. Why would you make a const reference? Well, passing by reference is faster than passing by copy. What if a string had 10,000 bytes in it? And we pass that in to say hello. It would have to copy all 10,000 bytes into it. It would have to put that 10,000 bytes, on the stack, and then when that function was being executed, it'd have reference to it. If it's a reference, though, then we're just passing a single pointer, an 8-byte memory address, probably, rather than all 10,000. So you can get some speed increases by making everything a reference. But if you make everything a reference, you're giving the code the opportunity to change the values. And an inexperienced programmer may think, okay, then I'm going to be able to, I'm going to be able to change X. It was passed in as a reference. It's totally cool for me to do so. But no, you really didn't want it to be changed. Maybe you were just making it a reference for speed purposes and not the ability to change it. And so in that case, you declare the reference as a constant. You're saying, I do want you to pass it in for a reference because that's the fastest possible way of doing it. But I don't want you to be able to change it. And so if that was the case, if we made this a constant reference, then we could pass this in. It doesn't have to be a constant, but it'll be treated as a constant throughout the course of this block of code. But this block of code is not allowed to change it. The same is true of putting constants into other places. I could have done this. There's no reason for me to have done this, but I could have defined each one of these as a constant here, and all that would tell me is that if later on I tried to do this, for whatever reason, the compiler's not going to let me do that because C is a constant, so it cannot be changed. Now in the calling code, it doesn't have to be a constant. When I call add3, let me undo that change. If I was going to do that, I'd have to modify the prototype to match. I'm going to just undo that change rather than continue following that little train of thought. Just know that you can define your variables to be constants, and if you define your variables to being constants, you're telling the compiler to not let you write code that tries to change those values. Using functions in menu-driven programs. You could use functions to implement user choices from a menu. Press 1 to run my geometry program. Press 2 to run my, turtle program. Press 3 to run this program. And so you could list the choices, and then inside your case or your if statements, then you could call the functions. To implement high general purpose tasks. Higher level functions can call general purpose functions, minimizing the total number of functions and speeding program development time. Sure. It's just the idea of breaking things into functions. That sure is a vague slide there. and I don't feel like going and looking at program 610. The return statement ends the function. You can place it anywhere in a function, not only at the end. Of course, if you put it above the end of a function, then the rest of the code won't run. Like, what if I do this? What if for some reason I just tacked on return 0 there? It's probably going to give me a warning when I build it. I would hope so. Oh, there were build errors. Is that something left over from my monkeying around that I did a minute ago? No, that's my warning.
You were showing the schedule.
I was showing something else. Let's get rid of that. All right. Now I've forgotten what I was just demonstrating. Oh my gosh. Oh, the return statements. Okay. All right. So over here in functions.c, when I call add 3, it's just going to bail out immediately. It's not going to do the rest of the code. The Java compiler would complain about that. It would say that's not, you have unreachable code. And whether it calls that a warning or an error, I do not recall. It might even call it an error. But you can put the return statement anywhere in there. An example of that is sometimes people have more than one way of leaving a function. You know, if condition. If a is equal to -1, for some reason we don't ever want to add a -1. And so if a is equal to -1, we just return a 0. Now that's moronic for the purpose of this function. Right, to add these numbers, it's moronic to check to see if one of them is -1. But there we do it. If we invoke this function, but the first piece of data passed in is a -1, then it's going to bail out and not do the rest of it. It's just going to return a 0. Typically, you see that if you're trying to rule out some kind of error condition. Like you're trying to stop a divide by 0. Or you're opening a file, but the file couldn't be opened. So you return early out of the function if there's an error state, otherwise you have a body of code that's going to be executed. Let's write a function that works like that, but I'm just going to go and stick it in our above our main. Let's call this function ratio. Void ratio, void print ratio. And it takes two variables, int x and int y. And what it's supposed to do is it's supposed to print the result of those two things. Cout x arrow arrow quote divided by in space end quote arrow arrow y arrow arrow quote space equals space end quote semicolon cout arrow arrow parentheses x divided by y, like that, arrow arrow endl. So down in main I'm going to call print ratio. Print ratio, what is 10 to? Well, 10 divided by 2 is 5. It ought to print 5. Okay, great. It did say that 10 divided by 2 is equal to 5. What happens if I make the second number a 0? We're going to have a divide by 0 situation. And it says unhandled exception. And just things are really at a bad point. And the reason why is because you cannot do integer division by 0. It'll do floating point division of 0 and not cause the program to crash like that. But integer division by 0 breaks the program. So we could put an if statement in here and return early if there's a bad case, if there's a bad situation. If y is equal to 0, curly brace, cout cannot divide by 0 /n, end quote. And then just return like that. Return semicolon. Now, is that the only way to structure it? No, of course not. We could have if something, else something, and then have the return statement at the bottom. But you see what I mean. You rule out the error condition early, and then the rest of your code can continue along its merry way for the rest of the function, having ruled out the errors. And this is one common programming paradigm. Rule out all the error states, return out early if you can, and then once you've proven that you don't have any bad data, then just go ahead and do the rest of the function. That can simplify the design of it. On the other hand, another rule of thumb is don't have more than one return statement in your function because it makes it hard to understand what it's doing. You just have to balance those things out. It is certainly an accepted design pattern to do it like this, where you're ruling out bad data at the beginning and then writing the rest of your code as though that bad data doesn't exist. That is a common way to do it. But if you start throwing in too many returns, and if they're mixed in the middle, 50 lines of code down here, you have some kind of if and a return, and then another 50 lines down here, you have another if and a return. It's real hard to figure it out. So basically, follow two paradigms. One is the idea that you can rule it out early, and other than that, you should only have one way of returning out of it. Two at the most. I don't know if I'm making a stupid statement by saying that, but those are the two competing thoughts. Only have one return statement, or using multiple returns to weed out error states early. So, returns can be used to prevent abnormal termination of programming, of the program, just like that divide by 0. In a void function without any return statements, once it hits that closing brace, it returns. So here, even though there's no return after this point, once it hits that closing brace, it does an automatic return. I could put that return there, and then if I was compiling this with a Java compiler, it would give me a warning. Unnecessary return. That's absurd to me. I like having returns on the end of my functions, honestly. I think it looks better. All right, let's go a little longer, and then we're going to break. Why don't we break now and come back at 8:50? I want to flip back to arrays for just a second, even though we've been talking about functions. And the reason why is I want to talk about filling data into an array versus processing it. And you don't want to try to do it in one loop. I'll show you what I mean. As always, I'm just going to tack something above main so that I can keep going there. Void food array. I'm going to declare an array of favorite foods. I'm not sure how many items I'm going to stick into it. Let's make it an array of 6. So I'm going to declare const int numFoods equals 6. And foods need to be strings. So string fav foods subscript numFoods. Like that. Now let's write a data entry loop. We're going to tell the user that we want them to give us 6 different foods. Now unfortunately, they have to be single word foods because otherwise we'd have to use getLine. Remember that you have to use getLine if there's going to be something with a space in it. And getLine is great, but once you start mixing up getLine with non-getlines, then you have to go through some trouble about clearing the input buffer to make sure that things don't go wrong. So our restriction is just that each food could only be a single word. Please enter your favorite foods. Cout. Note, each food can only be one word. I've got my /n on that one, my /n there. So we need a loop. Let's use a for loop to count. My favorite index counter is I. So for int I is equal to 0, I is less than 6, I plus plus. And we could use this with a reference type and not have to use the index if we so chose. But let's demonstrate it both ways. All right, so let's see out enter food number, arrow, arrow, I, arrow, arrow, quote, colon, space, end quote. And let's let them type it in. CIN, arrow, arrow the other way, CIN greater than, fav foods, subscript I. Okay, you don't want to put your loop that would process that. You don't want to print out the array or calculate totals or averages or anything like that inside your input loop. You want to break it up. You want to break your processing up. You're going to have a data entry loop of whatever kind, and then you're going to have your data processing loop. So now we can process it. We can display them. Cout favorite foods equals, and let's write another little loop, but let's use a range-based loop to print it out. For string v, I like v for value, colon, foods, cout arrow arrow v, arrow arrow, and a space, end colon. And then since there aren't any end of line markers there, we would want to print out an end of line there. All right, now I've goofed. Why is it giving me that grief there? Somebody will spot it right away, I'm sure. Do I have an array called foods? No, it's called fav foods. I never called the function, so it's not hasn't changed the behavior. But I wrote a function, I didn't call it. So down in main, I need to put a call to that function. I'll zoom back in. I know I have it zoomed way out. But down inside of int main, I'm going to call food array, parentheses in, parentheses, semicolon. So I tack that on as the first call to main. I mean the first statement in main. Now to zoom it back in. That's the top of the function. This is the data entry loop right there. And this is the data processing loop. And if you were doing an assignment where you were calculating scores or average temperatures or this or that, you know, it'd be a different kind of loop, but it still has to be separate from the data entry loop. Please enter food number 0, Jello, pizza, pie, chicken, tofu, whatever, oranges. And then it prints them out. Favorite foods, Jello, pizza, pie, chicken, tofu, oranges. Now, I don't really like it saying 0, 1, 2, 3, 4, 5. So when I print the numbers out just for their purposes, I might change them like this. I might say I plus 1 so that it says 1 through 6 rather than 0 through 5. Now, that's not going to change the way the program works, but it is going to change how they see it. Now, I really do want you to have this burned in about how to access these things with indexing. But since we're using this fancy language that has references, we could have written this data entry loop like this. But first I want to make sure that everybody's gotten what we've typed in so far before I go nuts. Right down here is a call to food array. Bless you. So we good? We can start hacking and slashing it? Okay. So what I'm going to do is I'm going to comment this data entry routine out and write a shorter one that uses a range-based for loop with a reference. So for string ampersand v, the ampersand means this is going to be a reference, colon, fave foods. All right, now we have a problem though. We don't have an index counter. We're not going to be able to tell them enter food number 1, food number 2, food number 3. That's the problem with using range-based for loops is you lose your index counter. But let's just deal with that. So cout arrow arrow enter food quote. Enter food colon space end quote semicolon, and then let's read into v like that. Okay. We lose our counter, but the syntax sure is nice. Comparing, having to do fave foods subscript I and then doing v. Kind of nice syntax, but this is the way you would do it in just about every other language that you're ever likely to see. So I'm probably going to wind up commenting this version out and leaving this version back in. But I'm going to put a comment above it saying what it is. Data entry loop using a range for loop with a reference variable. Big lengthy description. May as well test it and run it. Enter food. Pie, pie, pie. I really like pie. Cookies, cookies, cookies. And it prints them out. Pie, 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 cookies, cookies, cookies. But like I said, this is a C++ specific concept, the idea of this reference and using this reference to modify the array. So I'm going to comment that out and uncomment the other one. So going back up here, uncomment. And I'm going to add a comment, data entry loop. And then down here, I'm going to add a comment saying display loop, something like that. If we were writing a program to calculate totals or whatever, then you would use a loop, but you wouldn't be displaying them as you went. Instead, you'd be adding the numbers up. Have I managed to break y'all's code yet, or is it everybody doing okay? Alrighty, onward. Returning a value from a function. We know what that means. You issue a return statement in your code, and then that value gets passed back to the code that called it. So for example, we have a sum function that takes two numbers. We declare a result variable. Result contains the addition of those two numbers, and then that is returned, so that later on, somewhere in main or somewhere else, we can do something like this. We can say x is equal to sum, 22, 33. And so when this executes, all of this code is run, and the value that is stored in that variable is passed across the equal sign and assigned into that variable. Or if it's being sent out, to cout, something like that, whatever. It's just being used as though it were an int, because it's returning an int. So that's what the data is treated as once it's evaluated, once the expression is evaluated. So there's the return type, there's the value being returned. Notice that they declared result as a double, and then they returned it as an int. I'm kind of lost as to why they would do that. The only thing I could come up with is that if you add two ints, it's possible to come up with a number that's larger than an int. Not larger than the maximum value that an int can hold. But storing it in as a double and then returning it as an int anyways doesn't fix that. Here they didn't declare a variable. They just returned right away. Int sum, num1, num2, return. Well, Why does it say return num plus num? That's dumb, but it should say return num1 plus num2. You could write that function to do that. Just like in our code, in our functions, we didn't have to do this intermediate step of total is equal to a plus b plus c. We could have just done return a plus b plus c. Now, it's nice, in a way, to go ahead and declare a variable and then store your result in the variable before you return it. And the reason I say that is because if I was trying to debug a thorny problem, I could put a breakpoint there, and then I could see what it was going to return. So when I ran it, oh yeah, it would get to this point, and then I could watch it execute. I could do the step over, and then I could see, oh, total wound up being 6. Whereas if it was just return total all in one swoop, I wouldn't be able to inspect that value with my debugger. But it's totally cool to do that. If I'd wanted to write it like that, return a plus b plus c, well, obviously it's not going to be able to print this message out either. Just, if it makes sense to you to not store your results in a temporary variable and then just return them directly, go for it. As a matter of habit, though, I always declare my variable that's going to hold the return value. I assign into it, and then I return it. So returning a value from a function, I think it's about time to start babbling. Stop babbling. And let's give ourselves some functions to write. Write the following functions. Name, posneg. Or how about just name pos? Type, int. Returns 1 if the number is greater than 0, 0 otherwise. And so it needs to take one parameter. Parameter x. So what does it return? It returns 1 if x is greater than 0, 0 otherwise. That's one function I want to write. Another one's going to be neg. The name of this function is neg. Its return type is also an int. Its parameter is also called x. It returns 1 if x is less than 0, 0 otherwise. Now, what is it called if you swap the sign? Like if you have 3 and you turn it into -3, or if you have -3 and you turn it into 3? There's a math term for that.
Negation.
Negation, yeah. So, let's write a function. It's called negation. Its type is double. The parameter name is d. And what does it do? It returns 0 minus d. So it flips the sign essentially, or -1 times d. All right, let's do those. We have our little marching orders here. We have 3 functions that we want to write. Each one of these only takes one parameter, so they're not that hard yet. Okay, so here's the first one I want to write. I'm just going to copy out of that and paste it into my code so that I have it on screen, because my screen real estate is limited. So, as always, I just wind up sticking more and more stuff above main. Where's main? This is the function that I want to write. I'm going to denote it. I'm going to... are we still debugging? Stop debugging. Comment out all of this stuff. So let's write the name function. What is its return type? It's blatantly obvious there. It's got a return type of int. What's its name? POS. How do I define its parameter list? I use a parentheses. And I didn't say what type the parameter was, actually. That was my mistake. But just as an educated guess, we could make it an int. And it could also be a double. If we made it a double, it'd be able to accept any type of numeric data. I guess I should have been more specific and said that x was going to be a double. So I could go in here and say double x. And now it's just an if statement. If x is greater than 0, return a 1. Else return a 0. So if x greater than 0, return 1. Else return 0. Now I'm going to bring the next one over. And I'm going to let y'all write this one. Here's the specs for this one. Go ahead and write the neg function. Of course, I'll do it with y'all in a minute. Okay, so neg is going to look remarkably like this one. Int neg double x. If x is less than 0, return a 1. Else return 0. All right, now for that negation one. So, how do I define this one? If you're ready to go for it, tell me what that function header is going to look like. What's the first word of our function definition? Yep, it's double, and then the name of the function, negation, and then I have a parameter, so I'm going to put parentheses, and what should be in my parameter list? Yep, double space D. And this is supposed to return -1 times D. Now I'm kind of ignoring my advice to you of always declaring a variable and then returning that variable. I could break this up into that if I wanted to. You know, double result is equal to -1 times D, return result. But, you know, they do the same thing. I just made it slightly fancier to remind myself that I had shown you one thing and then I was demonstrating another. Okay, we're going to write another one. This function is going to be called isBig. Its type is Boolean. Its parameter is a long, named x, and returns true if x is greater than 2 billion. False otherwise. That's one of the ones we want to write. Now we're going to write one called greater than, or just GT, standing for greater than. So name GT, its type is also Boolean. I should call it bool. Boolean is the Java term. C++ calls it bool. Its parameters are 2 ints. int x and int y. And what does it return? True if x is greater than y, false otherwise. Alrighty, so is big. It's a bool. Bool is big. I should be typing this in my code, but it's got a parameter, long x. So it returns true if x is greater than 2 billion. Alright, so if x greater than 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, return true. Else return false. Alright, now I'm going to show you an alternate way of writing that. And this is probably how most people who've been doing a lot of programming would do it. They would just do this. Like that. That also meets the requirements, and it's one line of code rather than 4. Does it work faster? No, it does not work faster. It's just an alternate way of doing it. Why does it work at all? Well, because this is an expression that evaluates the true or false. And then the function just simply returns that. So if we passed x in and x was equal to 1, then it would go 1 greater than 2 billion. It'd go, nope, that's false. And so it would return false. So if you have a simple expression like this, and you're returning true or false based on that expression, you can probably modify it to do that. Okay, so that's is big. Where'd my other one go? GT. Has anybody done this one? And if you have, read it out to me.
Bool, GT,
So bool, GT,
parentheses, int x,
comma,
int y,
all right, close parentheses.
uh,
I need my brace. What am I going to do in here?
if parentheses x is greater than y.
Then return true. Else return false. Probably spaced out like a pro rather than what I was doing. Okay, notice one thing that you could do here is we could do the same thing. We could just do return x greater than y. But if we're not going to do that, you don't have to have it else there. You could just make it look like that. It doesn't make the program any faster, just demonstrating something. Because if you don't return true, then you are going to return false as a matter of course. So you don't always, if return statements are involved, you don't have to always have an else for every if because it's implied. But I sure do like seeing them, so I'm going to go ahead and say else there. All right, I'm going to paste this into my code, those two functions. Wow. Okay. Now I haven't tested them. We can trust that they work. All right, so I probably have gone too fast. Does anybody need any one of these chunks of code brought back up on screen? There's the last one we wrote, GT. Oh, I've got a boo-boo there. I didn't type in int y when you told me to. There you go. Okay, so let's at least test the GT function out. So what I'm going to do is ask the user for two numbers. Cout, please enter two numbers separated by a space. \n, semicolon. Now we need variables to hold those. Int x1, x2. So cin into x1, cin into x2, and now let's use that gt function. If gt x1, x2, then let's print out a message. Cout, the first number was larger. \n. Else, cout arrow arrow, the second number was larger. \n. So please enter two numbers separated by space. 1, 100. The second number was larger. Okay, so that worked. What I should do is I should have us write a test code for every function we just wrote. And when I turn around and I give you homework, I am going to ask you to write test code, for every function we write. Let's pick one more function and test it out. Somebody pick randomly another function we've written. We've written several. Which one should we do a test function for?
Isbig.
Yeah, isbig sounds good. So we're going to need a long. So let's ask the user for a number. So cout arrow arrow. Let's find out if a number is big. Give me a number. Sorry, you can't see the end of it, but you know that it's there. Give me a number, end quote, semicolon. Now let's declare a long called, I don't know, big num. And let's read into it. Cin arrow arrow big num. And write an if statement. If big num, no, if, wait, what did I call my is big? All right, so yeah. If is big, parentheses, big num, in parentheses, cout, that's pretty big, \n. Else, cout, that's not so big really. All right, that number was larger than 9 billion or 2 billion or whatever I said my limit was, so that's pretty big. All right, so I need to come up with a list of functions I want y'all to write. We have written several today, such as add 3 and multiply 3. Okay, so homework. Write a function named add 5 that will add 5 integers. Parameters. That's the first one. 2. More functions. Function name, square, return type, double, parameter, x, which is also a double, returns, POW of x to the power of 2. Another function named cube, and It's all the same, except it's going to return POW x to the power of 3. I've always wondered why square and cube have cute names, but taking something to the power of 4 does not. And so I Googled it up, and there's a possible name. You could call it a quant, a quart. I don't remember, but there's no such term. Okay. So let's do another one called mult. I'm just going to take this little template. Mult returns an int. Its parameters are x and y, which are ints. Returns x times y. All right, then a function named BMI returns a double. Its parameters are pounds and inches, also in double. And it returns 703 times pounds divided by POW inches, comma 2. All right, so that's going to be your homework, is to write those 5 functions. Then write code in main that tests the functions and displays appropriate output. That's pretty vague, but I'm sure you can figure out something. Alrighty, that'll be our homework. Let's see where we are in this. Returning a Boolean value. Yeah, you can return a bool. We've just done that. You can return any kind of data. You can return a string, a double, a long, a short, a char, a bool. The function type is defined as bool, and it will return either true or false, or an expression that evaluates the true or false. Oh yeah, that's the one to do. Function named is even. Parameter x, which is an int, returns, well, I didn't give it its type. It's Boolean. It returns true if x mod 2 equals 0. It's an even number. And then so let's specify the same one called is odd. Returns true if x mod 2 is equal to 1. False otherwise. So local versus global variables. Why are we throwing this in now? I guess because we're talking about functions, and so it's worth talking about. The way a global variable works. In Python, every variable you defined that wasn't in a block of code was actually a global variable. It's just we didn't really think of it in those terms. But in C, C++, Java doesn't have global variables. A global variable is one that's defined outside of all your functions, and that means that all your functions can access it. I'm trying to find main. Okay, so I can make a variable called bestBook, string bestBook. And I can have one function that sets bestBook, void set book, and it would set it to a value, bestBook equals The Hobbit. And then you could have another one that prints that book. print book. Cout the best book is, end quote, arrow, arrow, best book, arrow, arrow, ENDL. This is called a global variable because it's accessible to every function in this file. It's even accessible to code in other files. I could make functions.cpp access that variable, but I'd have to do it in a special way. So I won't mention that. I won't show you how now. So main here could call setBook, and then it could call printBook, like that. That's different than what we've been doing before, where we passed in data as a parameter. Having global variables is a way to avoid passing data around as a parameter. Is it good programming? Global variables are now considered to be pretty tacky, pretty poor taste, pretty bad design. There are usually much better ways of handling this kind of thing. It's better to pass data in as a parameter than to just rely on the fact that there's some global data out there. And the reason why is you don't know who is calling setBook at what time. You know, if you've written a complicated program, this function could be called, out of order, perhaps. You might be printing the book before it has a value set into it. Or maybe several different applications or several different functions are calling setBook, and so you don't know in which order. It's better to pass your data around as parameters than to rely on global variables. But global variables are a perfectly valid way of handling this kind of problem, where you want functions, data to be shared amongst multiple functions. Now this is called tightly coupled functions. You have to call them in this order. If you call printBook before you call setBook, the whole thing is, is for naught. Not going to work. Not going to print anything. Usually you don't want tight coupling from your functions. You don't want to write a series of functions that only work if they're called in a very specific order. But you can. So we've got a global variable here. Now honestly, when I write a global variable, I usually prefix its name with G underscore to indicate that it's a global variable. Now I'm going to write one more global variable called total. Int G underscore total. And I'm going to set total equal to 0, and I'm going to write a function called add. And every time add is called, it's going to add it on to G total. We might even return that value. Int add, it's going to take x as a parameter, and every time it is invoked, G total plus equals x, and then we return G total. So we could do this. Cout add 3 ENDL. And I'm just going to copy and paste that a couple of times. 3, 7, 100. And I would see that number increasing. All right, and so it printed out 3, 10, and 100. And if I go and compare against the code, against my calls to add, that looks right, because 3 plus 7 is 10, and then you add in 100, and you get 110. These are local variables. Local variables can only be accessed in the same function in which they're defined, and after the point in which they're defined. I can't use x1 up here, obviously, but that's, fundamentals level programming. We know that you can't use a variable until it's been defined, and that you can't use it in another function unless you pass it in as a parameter. But a global variable you can. All right, now I mentioned that we can get a hold of these global variables even from other .cpp files. Here's what you do. What if I wanted a function inside this functions.cpp to be able to access this total G total variable? I would go over here and I would define it, or I would put this definition in my header. Extern space int underscore G underscore total. That tells the compiler, yeah, we're going to be using a global variable called G total, but it's not defined in this file. It's defined somewhere else. It's external to this code. I'm not going to bother actually, showing that that works. Just trust that it works. If I wanted to write a function, we could write a function that would then access that variable, which is actually created in this file. We already had one called add. Let's write one called subtract. Int subtract, int x, and so g underscore total is going to be minus equal x, and then return g underscore total. And so if I put this as a header in the prototype, in the header file, if I put this prototype in the header file, I could access this function inside main, and it would be changing that global variable. It wouldn't matter where that global variable was stored. The compiler will hook it all up. That said, you can't have global variables in more than one file with the same name. If I try to declare another variable called g underscore best book in this one, that's going to be a compilation error. Or not. If you define the same function multiple times, it's an error. All right, I'm not going to take too much time to figure out why my statement is not true. Well, what do you know? How could that possibly work? How could you have two global variables? How would it know which one to access? Okay, finally, good. Managed to get it to cough up. Here we go. It says, a huge long variable definition. This is what strings look like underneath it. Class std : basic underscore string is already defined in July.obj. Now, if it had just done that to begin with, then I wouldn't have sweated it. Just accept that you can't define a global variable with the same name in more than one CPP file. You define it in one, and then you extern it in all the other ones that are going to access it. And the best place to put that extern is inside functions.h. So I just cut it and I moved it to functions.h, if you care to. All right, I'm going to undo that duplicate definition of best book. We're going to call this lecture about done. I'm going to move it back. I forgot I wasn't including that header file from both. To get that to work, I would need to include the headers file from the functions.cpp as well. So # include, quote, functions.h, end quote, or whatever you called it. All right. All right, so variables that are defined in a function are local to that function. They are hidden from statements in other functions, which cannot access them unless they're passed in as parameters. Because the variables defined in a function are hidden, other functions can have separate variables with the same name. That's no biggie. If you want to write 20 functions and they all have int x inside them, no problem. So the local variable exists only while that function is executing. That's the lifetime of the variable. When the function begins, that memory is allocated. When the function ends, the memory for that variable is freed. That means that any value stored in that local variable is lost in the calls between calls to that function. So a global variable is one defined outside of all the functions in a program. So the scope of it is any function in that program from where it's defined. If it's, written up above it, then that's not going to work. If you define your global variable at the very bottom of this .cpp file, the functions aren't going to know what it is. That's why you define them up at the top. This means that a global variable can be accessed by all the functions that are defined after the global variable is defined. You should avoid using global variables because they make programs difficult to debug. And they're saying that any global you create should be a global constant. They're saying, yeah, that's a legit use for it. Go ahead and use global variables, but make them constant, give them names in all caps, and we're all happy. That's their recommendation for when you use global variables. And I would pretty much agree that you're not supposed to use global variables. You're just supposed to know that you can. All right, let's make a Dropbox and call ourselves done. Are there any questions? That homework assignment look reasonable, writing these functions? Hopefully. All righty. Alrighty, if you refresh your Dropbox, you'll see Dropbox J. And I'll make a homework Dropbox 12 for the functions.